Hey everyone, welcome. We are Group 2 and today we're going to be talking about matrices. You might wonder what they are doing under the calculus heading, but we'll show you how these are actually really important building blocks for some calculus concepts. Let's get started. Before we dive into the math, let's quickly introduce our team. We call ourselves the calculus crew. We are the ones tackling this conquest of calculus challenges together. You've got IDID, Hori, and me myself, Hasif. So, why are we talking about matrices and calculus? Usually, when we start calculus, we're dealing with functions like fx, right? Just one variable. Matrices, on the other hand, belong more to linear algebra. Think solving sets of equations, or maybe transforming shapes. But where they come together is when calculus problems get more complex. Imagine functions with multiple variables changing, or systems where different parts are changing over time. To analyze those, you really need matrices. They give us the tools to handle the extra complexity. Think of it like going from adding single blocks, like example A, to adding groups of blocks, like example B. Matrices help us manage the bigger picture.
Question 1. Given that B equal to column row 1, 2, negative 3, negative 2, 4. Find inverse matrix of B, negative 1. Here is the solutions. B, negative 1 equal to 1. And multiply in the column D, negative B, negative C, and A. And the first step, determine B equal to A double D minus B multiply C equal to 2 multiply 4 minus in the column negative 3 multiply negative 2 equal to 8 minus 6, and the answer is 2. For adjacent B, we have 4, 3, 2, and 2. B negative 1 equal to 1 multiply 4, 3, 2, and 2, and equal to 2, 3 divided 2, 1, and 1. And next questions.
So, moving on to question number 2. Question is, find the value of A and B for each of the following matrix equations. So, as we can see, we've got this equation. So, this one is, we're going to call it uh, A, B, and C. So, from A, we can see that it is 1, 2A plus 5, 6, and 2. And for B is 3 minus A, negative A, 2, and negative 1. So, for C is negative 2, 10, 4b negative 4b minus 2 and 4. So how do we solve this? The first step is we're gonna subtract these two, and so we're gonna get 1 minus 3 equals negative 2. 2a plus 5 minus negative a equals 3a plus 5. 6 minus 2 equals 4. 2 minus negative 1 is 3. And then we're gonna put this together and we're gonna compare it to the other side, like negative 2, negative 2. 3, 3a plus 5, 10. 4, 4b minus 2, 3, and 4. We're gonna ignore this. And so from this comparison, we can make two equations to find the value of A and B. So for this one, we're going to take 3A plus 5 equals to 10 here, and 4 equals to 4B minus 2, and we put it over here. So how do we get the value of A? Firstly, we're going to move this 5 over here. So we're going to get 10 minus 5. And then we're going to get, so 10 minus 5 is 5. And then we need to move this 3 over here. So it's going to be 5 over 3. So the value of A is 5 over 3. And then for this equation, we're going to rotate this over here. So we're going to get 4B equals to 4 plus 2. So 4 plus 2 is 6. And then we divide it by 4. Then we're going to get 3 over 2. So the final answer for this question is A equals to 5 over 3 or 1.667, and B equals to 3 over 2 or 1.5.
Question 3. Write the following simultaneous linear equation in the matrix form and find the value of P and Q by using inverse matrix method. 2P equal to Q plus 6. 3Q equal to P minus 3. Solution 2P minus Q equal to 6 and negative P plus 3Q equal to negative 3. In the first column, we have 2, negative 1, negative 1, and 3. Multiply PQ equal to 6, 3. And first we have to find determinant A. Determinant A equal to 2 multiply 3 minus in the column negative 1 multiply negative 1 equal to 6 minus 1, and the answer is 5. Next is adjacent for A, that is 3, 1, 1, and 2. And the formula, the answer is A, negative 1, 1 per 5, multiply 3, 1, 2, and 2. The answer is 3 per 5, 1 per 5, 1 per 5, and 2 per 5. And the next step is S equal to A, negative 1, multiply B. P and Q equal to 3 per 5, 1 per 5, 1 per 5, and 2 per 5, multiply 6 and negative 3 equal to 18 per 5 plus negative 3 per 5 and 6 per 5 plus negative 6 per 5 equal to 15 per 5 and 0 per 5, and the answer is 3, 0. And the answer for P equal to 3 and Q equal to 0.
Okay, for the next question is question 4. Last question. Given that A equals to 3, negative 2, B equals to 1/3, 1, and C equals to negative 2, 0.4. Find the value of 6B, negative 2A plus 5C. Negative, we can call it also minus. 6B minus 2A plus 5C. So first we must find 6B. 6 multiply 1/3, 3. So equals to 2, 18. Next is negative 2A. Negative 2 multiply 3, negative 2. Equals to negative 6, negative 4. Last is 5C. 5 multiply negative 2, 0.4, equals to negative 10, 2. So we must solve 2, 18, minus 6, negative 4, plus negative 10, 2. Solve it all and we get the final answer is negative 14, 24. Conclusion. Basically, This example show the fundamental matrix skill you need to have down pat. Getting good at adding, subtracting, finding inverse, and using matrices to solve equation is like building a strong foundation. You will need this foundation to properly understand and use some of the more advanced tools and ideas you will encounter later in calculus, especially when dealing with the problem involving multiple variable or system of equation. That's all from me. Thank you for watching our presentation. Bye bye.